Hey, what's up everybody? Welcome to our flipped lesson on our next type of transformations, rotations. So a rotation is just when you're turning a geometric figure about a point, which we call the center of rotation. And for us on a graph, the center of rotation is always going to be the origin, and that's the point 0, 0, so right where the x and y axis intersect. The number of degrees that the figure turns is called the angle of rotation. And you should always rotate counterclockwise for this class, unless it's otherwise stated in the directions. So when we're thinking about rotating something, or turning a figure, we're not changing how big it is, so this is a type of isometry. The image and the pre-image are congruent, so we've now seen our three types of isometries: rotations, reflections, and translations. What I'm going to have you guys do now is save the rest of this page for in class. Doing rotations in the coordinate plane requires us to kind of turn our papers and do a little bit more hands-on learning. So we're going to save this for class time, and some other part of the notes is what we'll be doing next. So let's flip our pages over and get our paper to look like this, where we're rotating polygons. So when we're rotating regular polygons, an important thing to keep in mind is that you can divide a polygon, no matter how many sides it has, into a bunch of congruent triangles. And the central angle in a polygon is an angle with the vertex at the center of the polygon. So an example in this picture over here would be the angle MXN. So MXN, notice the vertex is right here at the very middle of the polygon. Whoop, don't want to do that. So when I'm trying to figure out a rotation, I need to figure out what my angle of rotation is. That's our first question in this example. We've got a regular hexagon, so meaning an object with 6 sides. And regular means that all the sides are the same length and all the angles are the same size. What is the measure of the central angle? So we're going to have to draw on some prior knowledge to answer this question. If I think about all the angles here in the middle, so these 1, 2, 3, 4, 5, 6 angles, all together they should add up to give me a circle, or 360 degrees. So if I want to figure out what just one of my little pie slices is, how many degrees are just in one of them, or my central angle, I'm going to take that 360 and I'm going to divide it into my 1, 2, 3, 4, 5, 6 pieces. And when I do, I come out with 60 degrees. So what that means for us is that each one of these little angles in here, maybe I'll type it, it'll be a little better, has a size of 60. So like this angle is 60, all the angles are 60 degrees. So now that I've figured out that angle X is 60 degrees, I can start answering questions about rotations. So part B, what is the image of point M for a rotation of 120 degrees about the center? So point M is my starting point, and I'm going to rotate that point 120 degrees counterclockwise and see where I end up. So I'm starting at M, and I want to go 120 degrees counterclockwise, so that way. If I go down here to point R, then I've gone 60 degrees, and if I go down here to point Q, then I'll have gone the whole 120 degrees. So when I am asked about the image, or if I start at M and I go 120 degrees counterclockwise, the place I end up for my image is just at point Q. And I'm done. So I wanted us to maybe try one or two more as part of our notes, and then the rest will be practice that we do in class. So we've got a new shape down here in our practice. Step 1 is going to be figuring out how big each of these central angles is. The whole part of this central part of the polygon all the way around would be 360. but I'm dividing that 360 into 1, 2, 3, 4, 5 equal pieces. So each central angle is 72 degrees. And if I were you, I would definitely write that in my picture. All right, so let's just look at number 1 and number 7 together right now as part of our flipped notes, and then the rest we'll do in class. In number 1, excuse me, I see that I want to do a 216 degree rotation of S about point Z, my point in the middle. So my starting point is S, and I want to rotate that 216 degrees counterclockwise. And you're like, oh my gosh, 216 degrees, like how do I figure this out? Well, remember that we're going to be counting by increments of 72. So if I go from S to R, I've only gone 72 degrees. If I go from R down to Q, I'll have gone 72 and then another 72, or a grand total of 144. And that's still not enough. But if I go one more to U, then I'll have gone 72, another 72, another 72, or calculator 72 times 3. That'll give me that 216 degrees. So I have to go from S, 1, 2, 3 spots to point U, and that would be the image or the place that I end up if I'm rotating 216 degrees. Number 7, another one. So what is the measure of the angle of rotation that maps T onto U? So that's a different type of question. In number 7, what they're asking me to do is start at T and go to U and tell me how many degrees you had to go. So I'm going 72, another 72, another 72, another 72, and then finally I end up at my destination, point U. So I went 1, 2, 3, 4 72s. Help me, calculator. 72 times 4. So I went 288 degrees to get from T to U. So that would be my angle of rotation. And we're going to answer a lot more problems like these two when we come to class. So be ready with any questions you have.